PileInspect, integrity testing of deep foundation piles, is a 3-year research project sponsored by the European Commission under the 7th Framework Programme Research for the benefit of the SME associations. In a year, 100,000 km of piles are installed in Europe. In cast-in-place piles, problems can occur during boring or concreting, leading to inclusions or openings in the pile. In pre-casting piles, problems can occur during pile driving, including spalling of concrete at the pile's head, or point and transverse or spiral cracking. If a failure is detected, the cost of that pile could be increased significantly due to the remedial work needed to replace it. Current NDE practices mostly applies to handheld hammers, commonly known as low-strain integrity testing or pile integrity testing. These are relatively fast to perform. However, the quality of the results depends strongly on the skill of the operator, and the results are always open to interpretation. It has been found that small defects that are less than a quarter of a wavelength are difficult to detect. PileInspect aims to develop best practice for inspecting the integrity of deep foundation piles, including cast-in-place and precast concrete piles. We propose to replace the instrumented hammer and pile driving hammer with a portable shaker, which will ensure repeatable, tailored excitation spectra and should dramatically improve accuracy of estimation of the proposed diagnostic features. The hardware prototype for the PileInspect system includes the shaker to create sine sweep excitation, the vibration sensors to measure acceleration of the shaker outputs and pile responses, the shaker amplifier to amplify input signals, the data acquisition card to record the sensor measurements, the laptop for the system control and signal processing. We also propose to employ highly innovative signal processing methodologies based on higher order spectra and impulse response function methods in order to increase the quality of pile diagnosis and perform automatic defect recognition. Before field testing, the developed PileInspect prototype was fully tested and evaluated under laboratory conditions in order to check for the ability of the prototype to generate excitation signals, check for the quality of the recorded signals from the data acquisition module, check for the prototype's ability to work correctly with the software. After tested under laboratory conditions, the PileInspect system was tested further and evaluated in the field trials. Integrity testing on real-scale piles was evaluated with precast concrete piles, installed in 2 Arslev test sites, one in Newark, UK, and the other in Kutna, Poland. The piles have different dimensions, including the lengths and cross-sections. Some piles were damaged at different depth points from the pile's top. Diagnosis of the piles were performed by the frequency response function, based on the chirp Fourier bicoherence. The full separation between the undamaged and the damaged features are achieved, which indicate 100% successful diagnosis for all piles. Integrity testing on real-scale piles was evaluated with cast-in-situ concrete piles, installed at the BAM test site. Some of the test piles have been seriously damaged during the dynamic load test due to tensioning. PileInspect prototype has been tested on 6 test piles, including 1 undamaged pile and 5 damaged piles. Pile diagnosis was performed by using impulse response function method. Pile toe and defects are clearly detectable, and the depth of the pile defects can be identified with high resolution and precision.